Hello students, today we will discuss the electric field intensity at any point due to an electric dipole. So as earlier we have already discussed that dipole is there, the axis joining this dipole axis is known as your axial line. So in axial line at any point that electric field is on axial point. So this we have already derived that E axial is equal to K 2P upon RQ. So that is K value is 1 upon 4 pi epsilon naught 2P upon RQ. Similarly, if that is on the equatorial line, then this equatorial line means from the center of the dipole we draw a perpendicular axis. So that is the equatorial point. So electric field intensity at any point on the equatorial line of the dipole, that is equal to K P upon RQ. So that is 1 upon 4 pi naught P by RQ. So similar manner, now we will discuss the electric field at any point. So suppose we have an electric dipole like this. So at its center, suppose this is O, this is minus Q, this is plus Q, and we have, suppose along this line, this is known as axial line, and this line is known as, that is your equatorial line. But at any point, so suppose we are considering a point, suppose here like this. So we are considering this point P, where we need to find out the electric field intensity. Okay, so in this case what we will do, suppose this is a dipole, so the dipole moment direction will be from negative to positive. So this is the direction of P. So this case we can consider that this dipole moment can be splitted into its two rectangular components. Suppose like this, this is A1 B1 and this is suppose A2 B2. So if we consider the point P, then by resolving the dipole moment P, which is making an angle theta with this axis, so we can write the component of P along this is P cos theta. Similarly, the component of P along this vertical direction, this will be equal to here P sin theta. So you can split this one into two rectangular components. One is vertical, another one is your horizontal. Now you can observe that this direction, the P point is on the axial line. So axial line, the direction of the electric field, this will be E axial. So E axial, that is E A1 B1 axis. So this is E axial. So this will be equal to your K 2P upon RQ. Already we have discussed earlier. And its direction will be along the direction of the electric dipole moment. So that is minus Q plus Q. So in the same direction. Similarly, if we consider the component of the dipole moment which is vertical, so this point is on the equatorial line to this vertical component. So for vertical component we know your electric dipole due to this electric field intensity will be E equatorial, and this will be equal to K P upon RQ. But in this case, in E axial, the P component is your P cos theta. Similarly, for the equatorial line, the P component is your P sin theta. So now, what will be the direction of the electric field intensity due to the equatorial line? That already, this is your negative 2, that is parallel to the direction of the, this is parallel to your direction of the dipole moment and opposite. So this is the dipole moment. So in opposite direction, this will be like this. So this is your E equatorial, and this is your E axial, what we have calculated. So the resultant of these two will be in this direction, and suppose it makes an angle of alpha. So we can find out here the resultant R, or the electric field E, will be equal to, you know, the angle between them is 90 degree. So we can put the parallelogram law. So this will be E axial square plus E equatorial square. So if we find out the value, so this will be your K P upon RQ. We can take common. So now we'll be having only this one as cos theta, that is 2 cos theta whole square, plus this will be sin theta square. So now we'll get Kp upon Rq, the square root of 4 cos square theta plus sin square theta. For sin square theta, I can write 1 minus cos square theta. So this will come as Kp upon Rq, and this will be 3 cos square theta plus 1. So this is the derivation for the electric field intensity at any point due to an electric dipole. Now this is a general derivation for the electric field. In this case, we can also put the condition for the axial line or for the equatorial line. If for axial line, the angle will be 0 degree, and for the equatorial line, the angle will be 90 degree. So you can put the values and we can check whether our derivation is correct. So now you can see that E axial will be, we can put the value of theta is equal to 0 in this case. So we'll get your Kp upon Rq. This is 3 cos square theta. So this is 3 cos square 0 degree plus 1. So this will be equal to, you know, cos 0 degree is 1. So this is 3 plus 1. So 3 plus 1, 4. So square root of 4 will be 2. So this will be K 2P upon RQ. So we can write this one as 1 upon 4 pi epsilon naught 2P upon RQ. So we get the same derivation as we have already derived in our previous classes. Similarly, for E equatorial also we can get by putting the value of theta is equal to 90 degree. So if we put the 90 degree, then you know cos 90 is 0. So this term will vanish. So now this is 1, square root of 1 is 1. So we'll get the value of is Kp upon Rq. So this is an important derivation and it is asked in your exam. So this is the magnitude part. Suppose we want to find out the direction. Then what will be the direction? In this case, you can find out the direction will be equal to, if you are taking 10 alpha. So this 10 alpha will be equal to, you can see here 10 alpha will be equal to the P upon B. So this is your E equatorial upon, this will be your E axial from this expression. So this will come as E equatorial is, you know, that is this one, that is K P sin theta upon RQ. So this will be K P sin theta upon RQ divided by, this will be equal to K 2P cos theta upon RQ. So this will be cut. So now we'll be getting the value as RQ. So this is 10 theta. So this is half 10 theta. So this is a important relationship for the direction of the electric field intensity at any point if the angle theta is between the reference line and the dipole. So 10 alpha is equal to half 10 theta. So this is a very important derivation. You all can practice, and in CBSE exam possibilities there you can get a question. Thank you.